Ellesmere Road. And then from Ellesmere Road, I can take Warden Avenue. That's all, right? Any shortcut? No shortcut, right? So this is how I should do. How do I know that? This is the way I should go. First time, who will direct you? You are new to Canada.
GPS.
GPS will direct you. How does GPS
Satellite.
know? Satellite know? How does satellite know?
Somebody.
Okay, we will go to the very old method. Very old method, right? We are looking at the street signs, right? Or we are looking at a policeman here. There's a police here, you know. He will say like, you go here, go here. So maybe a police is having some signs in the hand. Warden, Finch, like that, right? Or it's changing, right? So we come here, then the police will direct you. I will tell the police, okay, I want to go to Ellesmere. Okay, the police is directing, okay, then something should be there to direct you, right? Because if you continue to go, you may continue to go in progress. And if you continue to go there, you may pass a lot of other roads, Victoria Park and so on, right? You don't go to your destination, right? So I have to have somebody, what is the function of police here? He is routing you. Or GPS is also routing you. So we need to have, the person who drives is a driver. Person who is routing is a router. So you should have a router. So I should introduce a router if my network is quite big. Okay, obviously, right? Obviously, right? Not only from here to Warden, I may go to internet, right? So I may have a lot of routers in between, right? So how does router function? Same way as this function. Same way. Okay? So Progress Avenue is network 1. Network 1. And my host ID is 705. 705 Progress Avenue. Okay? So I am going to 400 Warden Avenue. So Warden Avenue is network 2. 400 is the address, the location address. Okay? So these are same network or different network? Different network, right? But before going to this network, this is 3 we assume. So we have network 2. We have to pass network 2, right? So router also has ports, but these are like Ethernet ports. We say E0 and this is E1. And also it has E2 and E4 we say. This router has 4 ports we assume, right? E4 is going somewhere else, Ethernet port 4. And E1 is going somewhere else, E2 is going somewhere else. But E0 is going to network 2, right? So this router also will have tables created. So network 1, if I want to go to network 2, how will I go? I have to go to, for network 2, which port should I exit?
E0.
E0. So it will have an entry E0. And also one hop, one jump. Okay, it will have that information also, right? Then if I want to go to, say, this is, we say after this we have, we assume that we have, there's no other road after Progress stops there. Kennedy, right? Okay, that's our problem.
It's Bellamy.
Pardon?
Bellamy.
Oh, we assume there is Bellamy here. It is not a continuation of Progress, but we assume, right? So E2 is, this is network 4. So network 4 is E2. So it has that information, right? So it will direct me, okay, you want to go to network 2, okay, go through port E0, right? From here you want to go to, see somebody there very quickly in this room. So you go through this door. But if you want to go and see Farzana, say hi, then go through that door. So it has that information. Who creates that table? Who creates? Router, how does router create a table like that? It's a little complicated table, not like MAC address table. It's more complicated because it can have information which is little further away also. So it's more complicated. So we use some protocols, right? Maybe we use some protocols called IGRP, okay, right? RIP, all those protocols we can use. We can use static routing also, right? We can type statically also, right? We can give that information to the router. Okay, so that is router. So router uses IP address or MAC address?
IP.
Router uses IP address. And this one uses, bridge uses?
MAC.
MAC address. And big cables and all, what do they use?
Cables, MAC address.
MAC address? But he doesn't understand MAC address anyway. Because if I have, say, for example, I have a hub here, the old hubs, right? Hubs doesn't understand, or repeaters don't understand MAC address. They don't understand anything. They just pass through. Pass through. They don't have any control, no flow control, nothing. You want to go? Okay, go. Right? They can't control. Whether it is busy or not, there's no control there, right? But this one can have some control. The devices in the little above this environment, right, have little more control. This has more control, right? So when you go up and up, you have more and more control, right? Okay. So if I want to transport a packet from one network to another network, what should I use?
IP address.
Router. IP address, but I use router. Okay. And the routing protocols are RIP, IGRP, all those are routing protocols, right? What we are using IP address. IP address has two components. What are the two components? IP address has two components. What are the two components? Network address and host address. Network address and host address. See, network address and host address. 705 Progress Avenue, right? Like that. But anybody here is responsible for anything? Anybody here is responsible for any activity? Okay, this guy's job is, okay, go. This guy does little flow control maybe. If it is busy, okay, go slow, go at least. This guy, okay, direct like a police constable. But they are not taking any responsibility to see whether your data is delivered. Are they taking any responsibility? No? Data, whether delivered or not, they don't care. They do their job, only flow control they can do. Okay? So there should be another person also to deliver, to make sure the data is delivered. One example of that, these are all hardware, right? One example of that is TCP. Even though IP works here, IP is providing services to TCP, right? TCP is getting services from IP. Okay, can you do that job? Can you make sure this is delivered? This guy is telling, the guys below, can you make sure these packets are delivered? If they are not delivered, let us deliver it again, right? Okay, I'm asking you to send a packet to another country. So it's your job to make sure it is delivered, right? That is your job, right? And you are getting other people to do your work. But how do you know that those people are delivering? Those people are not taking any responsibility, but you are taking responsibility. Okay? So that guy is TCP also involved, right? So we have to know about TCP. And also, earlier they had something called SPX, novel networks and all, they used SPX, right? Yeah. Okay. I want to deliver, okay, you want to deliver a packet to Harish, okay? So you want to make sure it's delivered, okay? You want to make sure it's delivered, right? But Harish you should establish a communication with him, right? Can you say, Harish, it's for you, can you leave it like that? Then Harish won't even look at that, right? So you have to say, hi Harish, okay, this is okay. Who are you? So you are Shabnam, okay, so this is the packet for you, so you have to accept it. After you accept it, okay, bye, thank you. You have to do that, right? So they should have a session. You should have a session, right? Like in Solaris, right? We use RPC, NFS. Those are session-related protocols. So we'll talk about that also in part 2, right? RPC. I wrote that. I couldn't. RPC, remote procedure call, remote procedure call. We are talking about only networking, right? If we don't have networks, okay, forget about all these things. We don't need any of these. We don't need any cable. You don't need power cable, right? You don't need any cable if you are not talking about networks. Network card you don't need. Do you need a network card for your computer if you are using it only for you? You're not sharing anything, you're not getting anybody's share. You don't need networks. Then you don't talk about this, right?
So RPC is remote process card.
Remote procedure call.
Procedure.
Procedure call. Procedure. We'll talk about that in detail later, right? Remote procedure call. For an example, right? For an example, I will call you later. Thanks. Say for example, if okay, say you are sharing something. You are sharing something. So you are sharing your car. Okay. So you are in a network, right? I am a client, so I wanted to access. First, you have to come to you. I can't just take the key, right? So I have to come to you and ask for that key, right? Then you have to, sometimes you have to have a procedure running called remote procedure call, right? And you have to register the service, the sharing service in that particular program, RPC, right? So anything to do with network related services, if I want to take any file shares from another computer, I have to use this one, right? RPC. So anything to do with networking, not for single computer. So that is also part of networking, right? So I had to create a session, okay? So this guy create a session, this guy make sure the transport is done, right? And this guy is finding the shortest path, the shortest time consuming path, right? To deliver the packets. And this guy is helping to do some flow control, right? And adding some destination MAC address, because everything is delivered based on MAC address. This guy is adding the IP address, this guy is adding the MAC address, like different departments. They are doing different functions, okay? So this is what happens in the network, right? But apart from that, there should be something else also, right? Because now I am sending some information from here to another computer which is here, and that computer is going to use that particular program in a different application, right? So I am recording this video, but when I try to open it, it may not open in a with a normal application. I may not be able to open. I may have to translate to another format. Maybe translation may be required, or maybe I am sending that compressed. So after sending, this guy has to decompress it. Then like that, lot of activities has to happen. Something like that, some activities like that has to happen. So there may be some encoding involved. Say for example, you are using Telnet. Is Telnet encrypted?
No.
No. But if I am using SSH, encrypted. So this guy has to work. Some encoding has to be done, right? And also sometimes compression. All those things somebody has to look after that, right? Yeah. And then
So who looks after encoding and encryption and compression?
there are different programs, right? Some ASCII format, right? Anything that can read ASCII format, anything can read JPEG format. Those are the people who are looking after that, right? Codings, different types of encryption, different compression. You learned about compression in part 1, right? Compress command in Solaris, right? So those are the people has to work in that area, right? Ultimately, the user has to use the application. That application should be a network application, not local application. But I can't use just Word. If the Word is installed in my computer, then I don't need all these people. If I'm using Word in my computer, why do I need all these people, right? All these areas, I don't need. So I will run my applications here. Can you give me some applications which are network related? Some network related applications?
Email.
Email. So when I send email, I have to use network. What are the other things?